Alrighty, so let's look at electric potential difference and potential energy. This is closely following what we were doing before. A charged molecular atom. So that's going to be either a cation if it's positive or anion if it's negative. So this is an ion, cation or ion, moves between two different points. Perhaps, I don't know, across a cell membrane, since this is physics of the body. When it moves across the cell membrane, this is our cell membrane, it experiences a potential difference. And so as a result, the energy of the charge will change. And since V is defined as U over Q, the change in energy will be equal to delta V times Q. So whatever my potential difference is times the charge of my charged molecular atom, whether it be sodium or potassium or whatever, then that's going to be the energy. The product of those two will tell us the energy of that particle. Charges tend to move towards lower potential energy. We'll see that come up later. Remember the mountain, if I have a positive particle, it's going to tend to roll downhill. A negative particle will tend to move uphill. So this delta U then will tend to be negative, because I'm moving from a higher potential to a lower potential, say from 4 volts to 2 volts. Then 2 minus 4 would be negative 2. So the delta U would be negative. Then positive charges will move so that delta V is negative. Right? So that would be like 4 volts to 2 volts. This would be the so for this positive charge, I would have a potential difference of 2 minus 4, negative 2. So that's going to be decreasing potential. While negative charges will move so that delta V is increasing. That is a positive potential. It's possible to move charges so that their energy does increase. See, in both of these, our energy, delta U, is going to be equal to Q delta V. In both of these, delta U will be negative. Right? If this is negative, that means that's positive. If this is positive, that means that's negative. But it is possible to have charges move so that delta U is positive, not negative. And we'll see that occurs so that their potential energy increases. However, this requires some source of energy. Like when we move an object up in the gravitational field. So if I have a block here that's sitting on the surface of the Earth, and I come and I pick it up and I move it up, what I've done is I've increased its potential energy. It has a positive delta U, but it had this outside source of energy that's actually doing work on the object. And we have that in our cells. To move charged particles, or to move charged ions, so their potential energy increases, that's going to come from something called the sodium-potassium pump. Hey, did you hear that oxygen and potassium went out on a date together? Yeah, it was okay. Yeah, so sodium is Na, potassium is K, and oxygen is O, so it's okay, right? So sodium-potassium pump. You may have heard about the sodium-potassium pump, and later when we get into cells, we'll spend some more time on that.